Dr. Faulkner, as I've been researching this whole issue, it seems like one of the most convincing arguments they have is the Bedford Level Experiment.
That's the thing that really set all of this off. There was a man named Samuel Rowbotham. He was English. He did a famous experiment in the mid part of the 19th century. The Bedford Level is a drainage canal in east side of England, and it's a very flat area near the ocean. It's this one section just straight as an arrow. If you had an object off in the distance over the curvature of the Earth, as you're looking at it, you couldn't see it because the curvature of Earth would get in the way. Now, you can do a simple calculation. It's an approximation, but it actually works very well for most distances of question here. If you go a mile, you get a drop of curvature of 8 inches. So if you mount a telescope 8 inches above the surface of the water, then in a mile's distance, it would be tangent to the Earth's surface, and then it would start to fall away beyond that. And each mile it's squared, so after 2 miles it would be 4 times 8, which is 32 inches, a little less than 3 feet, and then it would be 6 feet at 3 miles, and so forth. By the time you get out to 5 miles, 6 miles, the curvature would be close to 20 feet or so. And he reasons that if the Earth is curved, he should not see the boat, he shouldn't see the person in the boat, he shouldn't even see the mast with the flag on it. Well, lo and behold, he sees the mast, the flag, the boat, the person, he sees every bit of it. So he concludes that the Earth is not curved, it must be as flat as my desktop right here in front of me, and that way he can see the thing the entire way.
Rowbotham's experiment seemed to clearly show the Earth was flat, and that's what eventually led him to start the Zetetic Society, which was the beginning of the modern flat Earth movement. As Kyle and Pat did their research on this subject, they came up with the idea of recreating their own Bedford Level Experiment, but with a little twist. The Columbia River dumps more water into the Pacific Ocean after its 1,200-mile journey than any other. Its path creates the border between Oregon and Washington. So soon Kyle and Pat found themselves on the Oregon side.
This is part of the Columbia River at Astoria before the river goes into the Pacific Ocean. And this area right here, way across from just a little to my right where there's a foundation and a bridge and such, all the way to where nearly the river goes in is 6.8 miles. Now, what's special about that?
Well, at 6.8 miles, that's a little longer than they actually did for the Bedford Level Experiment.
That's right.
I think what I'll do is I'll go up to the top of the rocks,
Yeah.
Which should be above 10 feet.
Okay.
I'll wave the flag. We'll see
Yeah.
if you can see it.
Yeah.
And then what I'll do is once you see me,
Yeah.
I'll climb down
Yeah.
to the level of the water, and let's
Yeah.
see what happens.
Okay, so I'm in the car, I'm headed across the bridge.
Okay, so I finally made it here to the bridge, and I'm just going to wait now until Kyle calls me more than 6 miles away across the bay. So we're here to recreate the Bedford Level Experiment, and we're not the first ones to try and do this. As a matter of fact, if you watch on YouTube, there's a lot of different people that have done this, but a lot of them are done by shooting a laser across the body of water. Well, there's lots of problems with that. The first one is there's a lot of refraction that happens with the light, and it messes up the experiment. Also, what starts off as a little dot with a laser, by the time you get miles and miles away, can actually become very, very big.
I'll get all my gear in here and we shall head out to the sand to try and get Pat on the line. Here's that big lens.
So the way we came up with the idea for the flag is one day I was watching a YouTube video and they had guys with a camera on one side of a body of water, and then the other team was in a helicopter, and basically the helicopter was going lower and lower, and when this guy with the camera could no longer see the helicopter, they radioed each other, and the helicopter was actually a long ways away from the shore.
Okay, I have the camera set up now, and we just had a wave come in. In fact, that's not good because now the camera's sinking just a little bit, and I'm starting to see the roadway. That's amazing. 6 over almost 7 miles. A little bit of detail. It's rather windy, so it's a little jumpy.
Oh, here he is. Hello.
Okay, Pat, we're here. It's a little hazy still. Are you there now?
I'm as high as I can go, but again, I'm about 20 feet off the water.
I'm not seeing you.
at the end of the bridge.
I don't know, I'm kind of wondering if I need to go up higher. Whoa, this puppy is a heavy, heavy setup.
Hello?
Okay, Pat, I'm seeing cars way over there. I'm just not seeing ya. Okay, question, do you see radio towers behind you?
Yeah, there are radio towers way behind me on the other side of the bridge.
I can see.
I don't see how you can see that. It seems like the bridge is in your way.
Nope, I can see them.
As it turned out, the towers were another 7/10 of a mile past Pat, and both men hoped that such a visible landmark would help Kyle find him.
I'm having a hard time finding where the bridge starts and the land ends.
For that reason, Kyle gave it one more try by moving a little higher away from the water.
I'm still holding the flag. I got it spread between my two arms. I personally don't think you're getting enough definition on the camera for this to be able to work.
Yeah, I don't think we're gonna get it.
I don't think so either.
It was becoming very obvious that things were just not working out.
You know, we gave it a shot, so there you go.
Kyle and Pat were bummed out that they had put so much effort into this experiment, just to have it end like this. But then, as God often does, he was about to grant them victory in the midst of failure.
So after looking at the footage in the studio, I came back the next day just to look at these towers, because I was really curious. How tall were they? And what was the distance of the alternating colors, and how many colors were there? And I'm looking now. These towers have a brown base, and then they go up alternating colors between red and white, red and white, red and white, and red, with a signal light on the top. But these towers behind me, I think, gave a really good clue about the curvature of the Earth.
The bottom of the base of the left tower was about 4 feet above water level. The brown steel base is 7 feet tall. Each painted section is almost 28 feet in length. Using Google Earth, they learned that Kyle was exactly 7.52 miles away from the left tower. He moved to 3 different locations. At the first, with the camera 5 feet above the waterline, an online curvature calculator told them that the water at the base of the towers should be 15.25 feet below the horizon. From Kyle's first position at the edge of the water, Pat, and the part of the bridge he was standing on, was completely out of view. And you can see that much of the lower sections of the towers were missing. Kyle could just see the top part of the lower red section. But then when he moved up further, his camera was at about 8 feet above the waterline. And now the waterline at the towers should be 11 feet below the horizon. Here's what Kyle saw from this position. The part of the bridge where Pat was standing was still missing, and so was the tower base. But now he could see more of the first red section of the tower. Then Kyle moved to the third position with the camera now approximately 11 feet above the waterline. That would put the waterline at the towers just below 8 feet under the horizon. From this point, Kyle clearly caught the bridge and almost all the first red section. What they had accidentally caught on camera was exactly what they had been after in the first place. Their experiment clearly demonstrated the expected curvature of the Earth.